Hi everyone, Vega here, and in today's video I thought we might have a look at the world of Saturn. It's been a while since we've had a look at Saturn, and I really wanted to get back into the solar system series to have a look at the wonderful orange world. And it's come to my attention that when we're talking about the core of Saturn, obviously it's a giant planet, but many people these days seem to think that really the rocky worlds like Earth are really just the cores of giant planets. And you can sort of see that in our solar system, can't you? With obviously the larger the body, the more atmosphere it tends to have. Obviously, there are exceptions. Obviously, like Titan in the Saturn system, Titan's not actually a very heavy or massive world, but it does obviously have a thick atmosphere. And of course, our sister planet Venus actually has more atmosphere than we have, even though we are the slightly larger planet out here on Earth. But by and large, the more massive the body is, the more atmosphere it's capable of holding onto. So it does seem like large gassy worlds like Jupiter or of course Saturn, really they're just rocky planets with massive atmospheres, aren't they? I mean, we don't really know is the answer. We don't know if that's true or not. It says here that, interestingly, that Saturn's central regions are about 50% hydrogen by mass, whereas Jupiter's are about 67% hydrogen. So what that can tell us that if hydrogen obviously is the lightest element, that Saturn's central regions are actually slightly heavier, really, than Jupiter, and composed of heavier materials. And also, it says here the core is similar in composition to Earth, but is more dense. Now, it's quite curious, isn't it, really, that? Because we tend to talk about Saturn as being lighter than planet Earth, but it seems its rocky core is actually more dense, and Earth is actually the densest planet in the solar system. So if you take Saturn's atmosphere away, it's actually more dense than planet Earth, which is quite curious, isn't it? And it goes on to say here, it says, in 2004, scientists estimated that the core of Saturn obviously must be 9 to 22 times the mass of the Earth, which corresponds to a diameter of about 25,000 kilometers, which is actually almost twice as large as Earth. As obviously we can see here the Earth's diameter is 12,756, so it's about twice as large the mass, or at least the diameter, of the core of Saturn. However, it does go on to say here that there are other studies that say measurements of Saturn's rings suggest a more diffuse core with a mass equal to about 17 Earths and a radius equal to about 60% of Saturn's entire radius. So the question you probably have in your heads is, which one's right? Now, this second one here, talking about Saturn's rings suggesting a more diffuse core, there's not really any worlds in our solar system that we know of, that at least we can see, that are like that. Whereas there certainly are super Earth-sized bodies in the universe that we've encountered in exoplanets. So for me, obviously this is just based on a hunch and little else, I think it's more the first one. I think that Saturn has a large, what we might call a super Earth in the middle somewhere. And basically, wherever Saturn's formed, I mean, there are obviously theories that suggest it may have formed in the inner solar system and migrated outwards, or alternatively, it could have formed somewhere else. But if it did form, it certainly in the inner solar system as well, it's probably similar to the Earth. It's just that it had more mass and was able to accumulate more gases, and also able to hold on, possibly more importantly, to the hydrogen and helium that the Earth just isn't quite massive enough really to hold on to. We do have examples of super Earth exoplanets. I mean, if we look at the TRAPPIST-1 system, for example, we've got 1, 2, 3 bodies that are substantially more massive than Earth, 1.3 Earth masses, although you would expect that a body that has a diameter of 25,000 kilometers. But obviously those are super Earths, so there is a difference here, isn't there? And the core estimate of Saturn is 9 to 22 times the mass of Earth. And for example, those ones around TRAPPIST-1, I'm not saying that the TRAPPIST-1 system is particularly interesting for super Earths. And it says that sources generally agree that there's an upper boundary of around 10 Earth masses for a super Earth. So, and then obviously you go into the sort of ice giant planets, which essentially are a bit like really Saturn or Jupiter, but perhaps their cores weren't quite big enough to hold onto as much material. I don't think we really know why planets form in the size that they do. The point I'm making here, the curious thing, so obviously we've got a planet like Earth, and then you can get super Earths. Right, let's have a look at this one, Kepler 62e, which is the next step up, which we don't have in our solar system. Then planets like perhaps Neptune, and then up to Saturn. But when I say planets like Neptune, what I'm actually meaning is not the whole body itself, but the core of the planet. So we could make an assumption perhaps, and perhaps this isn't quite correct to do so, that maybe Neptune's mass of its core is somewhere slightly over the super Earth, and maybe Saturn's is perhaps the upper estimate of that. And obviously the core of Jupiter perhaps even larger than that of Saturn, although a bit unclear really. And then obviously after the core we've got all these extra layers that we don't have on our planet, like metallic hydrogen, liquid hydrogen and helium, which must be very curious places. So that's the core of Saturn anyway. Obviously it says very hot interior in Saturn, 11,000 degrees Celsius, and radiates 2.5 times more energy into space than it receives from the sun, which is unlike Uranus, isn't it? Which barely even registers at all. So Saturn's very much alive in that sense in its core. And then the outer atmosphere is 96% hydrogen and 3% helium. So obviously Saturn's atmosphere, in inverted commas, isn't really like the atmosphere that we have here on Earth. It's a very different composition, which you'd expect, wouldn't you, if the Earth hasn't held on to its hydrogen and helium. So again, it's when we say atmosphere, we have to also sort of be a bit careful about what we're talking about. I mean, likewise with Earth and Venus, Earth's atmosphere is mostly nitrogen, whereas Venus's atmosphere is mostly carbon dioxide. And of course, Titan as well is the only moon in the solar system with an atmosphere denser than Earth, as we know. This is quite interesting. It says it's one of only 2 moons whose atmospheres are able to support clouds, hazes and weather, the other being Neptune's Triton. Now, I know Triton has an atmosphere in inverted commas. I didn't know it could support clouds. That was quite interesting. And presumably Pluto too, because the difference between Triton's atmosphere and Pluto's is really not all that much. They're quite similar in that sense. But again, most of Titan's atmosphere is nitrogen, with a concentration, it says here, of 98.6, which again it's a bit like Earth really, isn't it? So let's just recap them. So we've got these huge gas giant worlds that basically could well be rocky worlds with huge hydrogen atmospheres. Then we've got ordinary bodies, a bit like Earth or Titan, that seem to accumulate nitrogen for some reason. Don't really know why that is. I mean, it says here the reason why there's so much nitrogen, even though there's no large amount of nitrogen on Earth. It says all forms of nitrogen in nature, such as nitrogen gas and diazote monoxide, or N2O, are volatile, so they accumulate in the atmosphere and not in the solid center. And the second reason being, since nitrogen-containing compounds are usually absent from the crystal structure, nitrogen atoms are not contained in solids located in the center of the Earth. And also another reason is that nitrogen molecules are more stable than oxygen. Obviously, oxygen is quite new to the Earth's atmosphere. It's not always been there. So we've got nitrogen being a bit of an oddball in the sense that it doesn't really want to form crystal structures and really likes to accumulate as gas rather than anything else. So that explains Titan, doesn't it? Because presumably it's the same reason as on Earth, that nitrogen is a peculiar element that likes to form gases, but it doesn't explain Venus. Although to an extent you could even say it does sort of explain Venus as well, because it says Venus's atmosphere is composed of 96% carbon dioxide, but it does have 3.5% of nitrogen, and if you were to take the carbon dioxide away, it basically has the similar amount of, I mean, just roughly off the top of my head thinking it can't be all that different to the amount of nitrogen in Earth's atmosphere. So really it's just the carbon dioxide that's curious on Venus. So we do have this pattern, don't we, developing of large bodies accumulating nitrogen atmospheres, and if they're larger, perhaps what happens is they turn eventually into gas giants like we've seen with Saturn and Jupiter and Uranus and Neptune. So there you go, a curious look at the beautiful orange world's core and what it might tell us about atmospheres of other bodies in our solar system. If you've enjoyed the video, take good care of yourselves, look after your friends and your families well, and I'll see you on the next one.